Sir Andrew John Wiles was born on April 11th, 1953 in Cambridge, England. He was an English mathematician who proved the hundreds of years old Fermat's last theorem, quoted the most notorious problem in the history of mathematics. Fermat's last theorem was that there are no positive integer solutions to x to the n plus y to the n equals z to the n for n is greater than 2. By proving this theorem, Andrew Wiles earned many honours in mathematics, such as the Abel Prize in 2016, the Royal Medal and the Shaw Prize. Wiles first discovered the Fermat's last theorem when he was 10 years old, and he quoted that at a 10-year-old he could understand and he knew from the moment that he saw it he would never let it go. He had to solve it. In order to do this, whilst he was in college, he studied the methods of the mathematicians who previously tried to prove the theorem, in order to gain any advantage he could for his own research. Andrew Wiles contributed significantly to mathematics by relating the proof of Fermat's last theorem to the proof of the Taniyama-Shimura conjecture. This unification of previously unrelated areas of mathematics under the Langlands program proved to the scientific community that different fields of maths could be fused to gain greater knowledge. The Taniyama-Shimura conjecture states that every elliptical curve can be associated with a mathematical object called a modular fashion. Wiles proved that if Fermat's last theorem was false, then therefore the Taniyama-Shimura conjecture would also be false, as there would be an elliptical curve such that it cannot associate with any modular form. Therefore, Wiles contributed greatly to the scientific community by conveying that it is possible to utilize two differing areas of maths to prove a theorem. Wiles' proof of Fermat's last theorem motivated other mathematicians to take on the challenge to invent new mathematics and proofs. This allowed the development of other fields of mathematics, such as elements in ring theory and algebraic number theory. For example, a French mathematician, Gabriel Lame, once published a general proof of Fermat's last theorem using cyclotomic fields. This proof was wrong as he assumed a unique factorization in cyclotomic fields, similar to the ring of integers. This led to Ernst Kummer's ideas about class numbers and Richard Dedekind's investigation of ideal rings. Both of these were used in the development of ring theory, made possible through the proof of Fermat's last theorem by Andrew Wiles. Wiles opened up new avenues of research, as due to his use of the Taniyama-Shimura conjecture, now problems in elliptic equations could be solved in the modular forms world, and vice versa. The impact of recognizing the underlying unity between these two branches of mathematics would allow mathematicians to better understand each branch. An area of modern mathematics based on the work of Andrew Wiles is the modularity theorem. Wiles' proof of Fermat's last theorem allowed the modularity theorem to be proved by multiple mathematicians using Wiles and each other's work. Without Wiles' work on Fermat's last theorem, they would not have been able to use the same techniques as him to solve the modularity theorem. In conclusion, Andrew Wiles is an amazing mind still alive today that proved the previously thought to be impossible theorem by utilizing previously unrelated areas of mathematics. His groundbreaking work inspired mathematicians like Kummer and Dedekind to progress in their own fields, and was the foundation of the modularity theorem. And he knew that he could do it all from the bright young age of 10.